So we've had a section on adding and subtracting polynomials. We had 2 sections on multiplying polynomials. And now you probably guessed there's going to be a section on dividing polynomials. And in fact, there's 2. And this is the first one of 2. So this is 4.7 and it's on division of polynomials. So it starts off in 4.7 just dividing a monomial, we did monomials by monomials. That was, what section was that? 4.2, right? A polynomial by a monomial, but division by a monomial. And so just a reminder that A divided by B can be written this way, right, in fraction form. And I put just, it doesn't matter what the signs are, they follow. And so if you have a trinomial divided by a monomial, you could write it like this. And then here's the kicker, is that you can break it apart and write it like this and divide the pieces. You can only do this if you have a monomial in the denominator. When you think about it, how do you add fractions together? You get a common denominator. Well, they have a common denominator, it's A, and then you add or subtract their numerators over the common denominator. So you're essentially just kind of going backwards from that. Then you can use the quotient rule that we learned in 4.2, because this is the kind of thing that we divided in 4.2, a monomial by a monomial. So we'll give a try to it. And so this is a trinomial, coincidentally, divided by a monomial. And so what they say is you can divide the pieces. So 12a to the third, b to the second, divided by 4ab squared, whatever sign, plus. And so it follows, the sign follows, ab, 4a to the fourth, b to the fifth, divided by the same darn thing. Sign follows. And then now I'm just ready to divide the pieces. 12 divided by 4 is 3. And here's the quotient rule comes in. A to the third divided by a to the 1, you subtract using the quotient rule. The exponents, 3 take away 1 is 2, a to the second. You can also use your fingers. A to the third means a times a times a. Divided by a to the first, right? And 1a, right? It's got the 3 a's up there in the top. I better write it like this. A over a, right? And then an a cancels with an a, leaving a squared. The b to the squared, b squared divided by b squared is just totally cancels, leaves 1. So 1 times 1 plus, so 3a squared times 1 is 3a squared. 4 divided by 4 is 1. A to the fourth divided by, here is a to the third, right? 4 take away 1 is 3. 5 take away 2 is 3. I don't need to write the 1. And so I divided 4 divided by 4, and I wrote the 1. And then I realized, well, 1 times a to the third, b to the third, is a to the third, b to the third without the 1. I tried to erase it, but it doesn't erase very well. And so, and then here, 16 divided by 4 is 4. The a's cancel and the b's cancel. Sometimes people say, well, what if I use the quotient rule? And then you would have subtracted them. 1 take away 1, right, which is a to the 0. Yeah, what's a to the 0? Do you guys remember? It's equal to 1, right? And so anyway, so this is my answer here. These are not like terms. I cannot add them together, so I'm done. Now, this one is written as a division like this, right? So I can rewrite it like this and then rewrite it like that, or I can go straight from here to there. It's divide the pieces, as long as this is a monomial. Well, and it is. Negative 9t to the second is a monomial. So the signs follow here. 36t to the sixth minus 27t to the fifth minus 9t to the second. And you're going to divide each one of these, every single one of them, by negative 9t to the second. I can hear my sons. I probably guess you can hear my sons, and so I'm going to go shut the door. So 36 divided by -9 is -4. T to the 6th divided by t to the 2nd is t to the 4th. 6 take away 2 is 4. A negative divided by a negative is a positive. 27 divided by 9 is 3. 5 take away 2, because quotient rule, right? When you divide those, quotient rule, subtract. Coincidentally matches. It's a coincidence. And then here I get a negative divided by a negative is a positive. 9 divided by 9 is 1. T to the 2nd divided by t to the 2nd is 1. And you have to write the 1, because 1 times 1 is 1, right? So over here I didn't have to write the 1, because 1 times a to the 3rd, b to the 3rd, is a to the 3rd, b to the 3rd. And so, but if you don't have anything else, 1 times 1 is 1, right? So you don't have to write the 1 if you have something else. 1 times anything is the anything. And so there we've done a lovely job at it. You can't add those together. They're not like terms. So this is just your answer. And that's all this section had in it. It's a pretty short section, actually, is dividing a polynomial any size by a monomial. And no matter what the size is, if it's a trinomial, you'll have 3 of these. If you have a binomial, you just have 2 of these. If it has 4 terms, then you have 4 of those, whatever. But that's the story on those. So it's a pretty short section. We did a lovely job on it. And I'll see you in the next section.